Okay, so try to record as much of this as possible. Um, what did we find out last time about arc sine? It's not the reciprocal of sine. What is it of sine?
What? Yeah.
The inverse, right?
The negative one thingy.
Yeah.
Right. Yeah.
So, um, yeah, on the calculator it looks like it's raised to the -1, so people kind of get the wrong idea about it, but it's the inverse of sine the way that square rooting is the inverse of squaring, right? So if I have two things and their inverses side by side, I just get the thing back, because if I take a number and I do something to it and I turn right around and undo it, I'm going to get the same number back. So problems that look like this, where they have the arc whatever right by the function, like this one does, sine and arc sine, you're just going to get, like, that would just be 0.7. That's why I kind of hate that I picked that one. Oh, but there's a lot of them in there. That's what's going on in 29 through 45, right? Or 43. Not all of them, though, and that's why that's okay. I picked one. That'll give you an idea how to do 31, 33, 35, 37. All of those are like that. Okay, so just, kind of tune into the fact that so that you would recognize it if you saw it on a quiz or test. Okay, so not all of them are like that, though. Let's pick one that's not like that. Let me pick 45. Okay, we have the arc sine of the cosine of negative pi 6. Okay, so let's draw to represent what's going on. What would pi over 6 be? If it's negative pi over 6, that means we're going clockwise. What would that angle be?
30.
Let's see, yeah, 180 divided by 6 would be 30. Good. Okay, so we're talking about a 30-degree reference angle here. And what else should I label this figure with so I make sure I get it totally right?
Angles.
What's this?
Oh, right.
What does that help me make sure I'm doing right? Yeah, and all the signs, right? Okay. So if I label it, now I can go, okay, the cosine is supposed to be negative pi over 6. But the cosine's positive in the fourth quadrant, right? So are we really talking about that angle? What other angle could it be referring to if it's not that one? Where's cosine negative? Wait a second. Never mind. No, that's right. I need to be thinking that way. Where? Second and third quadrant, right? So that, oh, okay. I'm jumping ahead of myself here. We're fine here. Okay, this is just telling us the angle. Sorry, I'm like having slow brain day, like a while ago with Elizabeth. Okay, so what is the cosine of 30 degrees? A half? Let's see. A half is sine of 30 is a half. So cosine of 30 would be the other ratio, square root of 3 over 2, okay? Square root of 3 over 2. If you don't remember it that quickly, try to get to the point where you do, because if not, this is going to be an extremely painful lesson for you, okay? Try looking back and kind of getting at least if you can get sine 30 is a half, and you know the other ratio is square root of 3 over 2, and then they just flip for 60 degrees, right? They switch out. So this is going to be square root of 3 over 2. If you don't remember that, you're going to have to go draw your 30, 60, 90 and label it and figure it out, okay? So you can always go do that. You just hope you don't have to do it as much as time passes. All right, so now, what is this saying? If I have the arc sine of square root of 3 over 2, what is this asking me to find now? What do arc cosines and sines, what are we doing? We're finding the angle. So it's asking me to find the angle who has, or which has, I guess it's not a person, a sine of square root of 3 over 2. That's what that statement is saying right to me right now. Okay, so what angle has a sine of square root of 3 over 2? 60, okay? So it would be, we have a reference angle of 60 degrees. And since it's Here's what I was doing. I was getting some of these things backwards here. When we have cosine of something, it's asking us to find the ratio of the sides, right? We can draw the triangle, we can do all that, figure it out if we don't remember it. But when we see the arc sine, it's asking us to think backwards. It's asking us to say, well, what angle has that ratio square root of 3 over 2? So that's why it's really good to have a lot of those 30, 60s, and 45s memorized. I don't memorize, and maybe some people probably do, but I don't memorize the 90 and 180, 360, 2 pi, 0 thing. I draw it out all the time just because it's kind of weird anyway. When you start putting stuff over stuff, you start getting undefined. So it's just too much for my brain to hold. But the 30, 60s, and 45s are good ones to have committed to memory because almost everything you're going to do in here is that, okay? Most of these problems are going to come back to that, okay? So if I'm going to look at this, we're talking about arctan now. It's kind of like they've switched the place of some of this stuff from 45. If you look at 45 in this, here we start off trying to figure out an angle, right? Sort of, but not really. It looks like we need to know the angle that has an arctan of 4/3. What it's really telling me is here's the angle, and I'm trying to find the angle whose tangent is 4/3. So how could I use SOHCAHTOA to help me label this triangle?
Whatever your tangent is.
Yeah, tangent is opposite over adjacent, isn't it? So that means the side opposite this little angle is 4, and the side adjacent to it is 3. Okay? All right, so what kind of triangle is this? We could do the Pythagorean theorem. Do we need to? 3, 4, what? 5. Okay? One of those triples. If you notice, if you look in there, 49 is also a triple, 51 is going to be a triple, 53 is not a triple, so we can do that after this one. Okay, so if I go look at this one, now they want to know, do I know the angle? I don't know it, do I? I just now have the triangle labeled, and you know what? I really don't need to know it because this sign is now on the outside. It's telling me to take the sine of that angle. It didn't ask me to write the angle down. As a matter of fact, I'd have to have a calculator to do that. So what's the sine of that angle? Sine. Yep, opposite over hypotenuse. So it'll be 4/5. Good. So that's your answer here. Most of the time in trig, we don't know the angles unless they're those 45s or 30 or 60s or 90 increments. But a lot of times we don't need to know it either. And so especially here, don't fret that you never know the angle, okay? Because a lot of people get hung up on that. Okay, so we have arc cosine negative 2/3. So we're looking for an arc cosine is always, I'm trying to find an angle, so I don't know the angle. I'm going to mark it on a right triangle because I need to label the sides, and I have to label it from a specific angle, right, even if I don't know what that angle is. So cosine is, thinking about SOHCAHTOA, isn't that adjacent over hypotenuse? Okay, so this is going to look weird. The adjacent side is negative 2, so it looks weird to have a negative value there, but remember, if I were to draw this on the coordinate grid, I could put it here, and that actually would make sense to have negative 2 here, wouldn't it? Okay, and then it's 3. If you think about it, if I had drawn it on the coordinate grid, that would be like 3 there. So even though you're getting these negative values, it actually can make sense. Honestly, you don't have to go down here and draw it like this, like I did. You can just label what you see, and it works. It all works out. Because if I'm going to have to do the Pythagorean theorem here. There's not a 2, 3 something triple, is there? So it's going to be the square root of negative 2 squared plus 3 squared, right? Isn't that how we find the hypotenuse? So that'd be what, 4 plus 9 is the square root of 13. Okay, so I've labeled my triangle. I'm done with that inner piece of it once I get my triangle labeled because I don't really need to know the angle. It's not really all that important here. They just want the sine of that triangle. So what will I do now? I'm sorry, sine of the angle. Blah, 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 blah. See, brain, mouth not coordinating well. Well, remember, sine is opposite over hypotenuse, right? So it would be, opposite is 3 over, yeah, and then I have to rationalize it. So we'll multiply by square root of 13 over square root of 13 to rationalize it. And And we get, what, 3 squared roots of 13 over 13?
Yeah.
So what we're going to do is we're going to go ahead and draw our right triangle just like we did in the problems above. And this is a cosine ratio, and arc cosine's talking about the angle that has that ratio. Well, if that's the cosine ratio, cosine, let me mark an angle first because I always have to label from an angle, so I'm just going to pick an angle. Y'all can pick a different one and if you want to. But this cosine is adjacent over hypotenuse. So my adjacent side is 3, and my hypotenuse is this mess. X square root of x squared minus 2x plus 10. So I'm missing a side, and of course they asked me for the sign, which is going to involve the side that's missing. That's, how they do this. So what am I going to do to solve this?
I would factor something.
You would think, but if you look at it, you got 3 over there. And anyway, it's just, you would think that would be what you would do, because that's factorable there, right? So, well, or is it? 5 times 2 is 10. It's actually not factorable. So, yeah, okay, but it's not as big a deal as you think. Let's call this missing side B. We can do the Pythagorean theorem. Yay. No, that's why, yeah, these are not. Most of them aren't this bad. If you look at them, most of them are a little simpler. Okay, so if I do the Pythagorean theorem, 3 squared plus b squared.
Equals x squared minus 6.
Yeah. And what do I do with that? Because it's a squared plus b squared is c squared, right?
Well, yeah, I just took away the radical.
Okay, yeah, you could, yeah, oh yeah, I see what you're saying, okay.
Unless
So,
I'm doing it wrong.
no, you're fine. 9 plus, no, you're fine. I just didn't, like I said, brain is working a little behind. It's out of sync today with the mouth. All right, so if I want to find this, I'm going to subtract 9 from both sides, right? So x squared minus 2x plus 10, and then I'm going to move the 9 to the other side by subtracting it from both sides. So if I simplify that, so what I did was subtract 9. Hopefully all you guys saw what I did there. So that's going to be what? B squared is x squared minus 2x plus 1. Now, is that factorable? Yep. Okay. So it would be b squared is x minus 1 squared, right? X minus 1 times x minus 1 would give me that. So I'm just going to write x minus 1 squared. They might not all come out like that, and if they don't, you'll just have an ugly expression, You don't actually, if they don't factor to a perfect square, you're probably just going to have something that looks like what we started with up there under that radical. So if I square root both sides, b is actually x minus 1. So the value there, okay, now I got the side. Let me go label it in red or something. This is now x minus 1. So now if I want to find the sign is, so opposite is x minus 1 square root, yeah, over the craziness. And you know what? I'm not even going to tell y'all to rationalize it here because they gave it to me not rationalized, correct? If they give you something and you're wondering what to do with in a problem like this, you can always give it back the same way they gave it to you. That's kind of an unwritten rule of math, So we don't have to go we're not going to go rationalize that. We could, and it wouldn't be that hard. It's just ugly, okay? So we're just going to leave it like that because that's how they gave it to me. So always kind of make the assumption that if you're given something, for instance, in radians, you're going to give the answer in radians. If you're given something and it's not simplified and they don't tell you to not rationalize and they don't tell you that you have to do it, you can always give it back the same way, okay? That's just